Okay, ladies and gentlemen, this is Tuesday. Test is Thursday. Whose birthday?
Birthday today, my dad.
Oh,
And yesterday was my mom.
really?
Oh, that's so cute.
That is. Happy birthday yesterday to Mrs. and today to Mr. Rhodes. All right, 15 through 18. We did 1 through 14 yesterday together, so we're on 412, and I am very ambitious today to cover a lot of ground, so hopefully time will fly because when you're very busy, time goes faster. So ready? Here we go. Number 15. Use the coordinate notation to describe the translation from the blue to the red. Do you understand what they meant?
No.
Coordinates are always written X, Y, right? They're called ordered pairs. So when we went from blue to red, what happened to the X and what happens to the Y? That's what they're getting at. What happens to the X and what happens to the Y going from blue to red has to happen to all vertices. All points in that pentagon have to move this many places. What'd you get, Isaac?
Minus 5x.
We're going from blue to red.
Oh, blue to red. Oh, not bad. Then plus 5 and plus 4y.
Okay, everybody's eyes are up here. Oops. To go from blue to red, all your X points increase by 5, and your Y points, vertices, increase by 4. Let that sink in a minute. I'll say it again. To go from the blue pentagon in the third quadrant to the red pentagon in the first quadrant, all you had to do was take all your X points and increase them by 5, and all your Y's and increase them by 4. And you take that whole figure and you basically slide it up to the right. One more time. You're translating the pentagon from the blue, sliding it up to the right. How's that happen? All 5 vertices move in this way. Whatever the X was, add 5 to it. Whatever the Y is, add 4 to it, and all of those points move together. One more time.
Yeah.
If you let's look at the very tip of the pentagon. Everybody, focus your eyes, number 15, on the point to the pentagon. Almost looks like a pencil point. The blue one. The blue one in the third quadrant. Everybody's eyes there? Okay. What's the X coordinate of that point? What's the X?
-4.
No, what's the X of that point?
-1.
-1. Hold on. We had somebody say what? You don't see that is a -1 X? It's 1 to the left. What's the Y coordinate for the point, the pencil point of that pentagon? Spencer? -3. Okay. Now look at the red pentagon. Some people aren't focused. Look at the red pentagon and tell me its coordinates. The point. The same point that you just gave me the coordinates in the blue one. What are the coordinates for that point in the red one, LP? 4, 1. What happened to go from -1 to 4? You added 5. What happened to go from -3 to 1? You added 4. So you interpreted, you figured out what they did to move from blue to red was they added 5 to X and 4 to Y. And now the same exact shape is now not in the third quadrant, but up there in the first. Why? Because you figured out what they did to all the points. All 5 points of that pentagon were moved. +5, +4. What kind of transformation is this?
Translation.
Translation. You're sliding it. SL, translation, sliding it. Number 16. Now that you have a better grasp, I hope, what did they do to all four vertices in that trapezoid to move it from down there in the first quadrant up to the left? Remember, we're going from blue to red. If you could see and perceive what I see and perceive. Anybody besides the hands that are up? Waiting for more hands to go up. Waiting for more minds to get engaged. Waiting for more focus and, hey, I'm going to really focus here and figure out what this is. You've got a trapezoid there in blue, and it's moved up and to the left. How did they accomplish that same exact trapezoid and sliding it up to the left? What did they do to all the X's, and what did they do to all the Y's? David, what do you got?
They subtracted 5 from the X.
Go ahead.
And then you add 5 to the X.
Not 5. All right, let's focus, Micah, on the bottom left corner of the blue trapezoid. Dina's going to tell us the coordinates of the bottom left corner of the blue trapezoid. Dina?
Okay. Okay. 1, 1.
No.
Sorry. Wait, no. 1, 0.
Nope.
0, 1.
Run before you jump.
I know the answer.
Which one is it?
0, 1.
0, 1. So the bottom left coordinate is 0, 1. If you're awake, say, I hear you.
Amen.
If you understand what I just said, say amen.
Amen.
Not as many amens as I hear you. So at least we're awake, even though we're not fully focused. Here's what we've done in the last 30 seconds for those of you that still haven't tuned in. The X and the coordinates for the bottom left corner of the blue trapezoid in number 16 are 0, 1. Raise your hand if you don't understand why that point is labeled 0, 1. You don't understand that? Okay. Start at the axis, the y-axis. Do you move to the right? No. Do you move to the left? No. That point is right on the y-axis, therefore it's at 0. You didn't go left or right. You with me?
Yeah.
Okay. Now start on the x-axis. Are you going to go up or down? You went up. Noah. 1. That lower left corner is at 0, 1. Now, look at the lower left corner of the red trapezoid. What are its coordinates, Mr. Mitchell? Thanks, Mr. Mitchell.
Which one?
The red one. The red,
one. Which one?
the bottom left corner of it.
Bottom left. That is -5 and 4.
-5, 4. You know, this makes no sense to you unless you fully engage. You got to fully engage your mind. How did we get from 0, 1 to -5, 4? What happened to the X and what happened to the Y? And by the way, since they're congruent shapes, this happens to all 4 points. What happened to the X and what happened to the Y, Dina?
Well, I have a question. Why did you do like the x-axis and then the y-axis, but then for the first one you did like the y?
No, dear.
Like you did.
It's always X, Y. It's always moving left or right and then up or down. Kara. I don't even hear you.
X plus 6.
So you're saying to go from 0 to -5, you add 6. Think about what you're saying. The same corresponding point went from 0, 1 to -5, 4, and you're saying they got from 0 to -5 by adding 6? How'd they get there? By subtracting 5. And how'd they get from 1 to 4?
Adding.
By adding 3. And they had to do that to all 4 points in order to maintain that same trapezoid in a different position. Listen, it's not as hard as you're trying to make it out to be. Look at the coordinates, see where the point is, see where the other corresponding point is, and figure out the difference. Negative, subtracted 5, added 3. That's it. We make it hard. If you really focus and listen, simplify it. Write down the 2 points. Subtracted 5, added 3. You don't have to do it for every point because you already know they're congruent. You already know it's the same figure being slid. So you don't have to do it for all 4 points. You only got to do it for 1. Yes?
So we always start with the x-axis? So like,
Okay, no, time out. You just said always start with the x-axis. No, you always start with the x-coordinate, which is taking you left or right of the y-axis. Maybe that's where your confusion is. The x is movement. Listen, Dina. The x-coordinate is moving right or left of the y-axis. We run before we jump. So x is where are we at in relation to the y-axis. I can see how that's confusing until you process it. But x is always moving horizontally.
why is it 0, 1? I don't know.
Y is 0, 1 on number 16, the blue trapezoid. Look at it. How far did they go to the right of the axis? How far did they move right? This is the origin. This is where you always start.
Okay, never mind.
Right?
I think I get it.
You always start right here. What's this called? Origin. Before you plot any point, you always start right here. And in that point, you don't go left or right. So we call that 0. And then you go up 1. So we call that 1. That's where the point, the lower left point to that trapezoid is. Yeah? Everybody good? All this ground we're covering. Number 17. If PQR has these vertices, 0, -1, 3, -1, R, or 5, -3, what are the vertices if we translate it -5 plus 1?
Oh,
6, got it. Go. Oh, yeah, they're up there. Anybody? We got 1. We got 1 confident that they know the answer. 2, 3, 4. This is 17. So far we know that there's a triangle with...
yeah.
Go ahead, Jaden. Shh. Where is the point P now?
-5, 0.
Hold on, stop. Focus. Casey. She said point P is now at -5, 0. Do you agree? Anybody disagree?
Oh, no.
Anybody not agreeing or disagreeing because you still don't know what's going on? And if that's the truth, I can't fix your focus. You got to do that. How did she get -5, 0? She went from P being 0, -1, and they told her they were sliding it from 0, they were sliding it -5. So now she's at -5. They told her that the X or the Y coordinate was -1, and they told her they're sliding it +1. So -1 to +1 is 0. That's it. Write the coordinates, add or subtract what they tell you to add or subtract. Go ahead, Jaden. What's Q?
-2, 0.
-2, 0. And R?
0,
-0, -2. Very good. Number 18. LMN has the vertices 4, 2, 0, 3, and 1, 1. And now they're moving it +1, -6. All you're doing is looking at the ordered pairs, adding 1, subtracting 6. Hello? Seth? Add 1, subtract 6. We're not asking you to divide by 0.0006. We're not asking you to multiply by 4 digits. We're saying add 1, subtract 6. Here's the first point. 4, 2. We don't have to write it down. Use your head here. Add 1, subtract 6. 4 becomes 5. 2 becomes, we're subtracting 6. Negative 4. You with me?
Yeah.
Whatever they say to do, you do to the x and y. 1, negative 3, 2, negative 5. Test is Thursday.
Why? Is there a map on the
We're still moving. Still moving. One more thing. One more bit of new information. And then we start review. We still got, wow, how much time I got? 20 some minutes? All right.
2 minutes.
All right. We've talked about congruent shapes and how they can be mirror images of each other by reflection. And we talked about how we can move that shape anywhere in the grid, right? By, what's that word called again? Not by reflection. We can move it by translation. You're skipping a page, and we're not doing tessellations today. And you're going to page 416, where not congruent, but similar polygons are introduced. What's congruent mean, Bella? Listen up, I can't even hear Bella. The what?
The sides are equal and the angle.
Okay, so simply put, she said the sides and the angles are all equal. That makes it congruent. Simply put, it's the same size and shape. Here's the difference between congruent and similar. Similar shapes are the same shape, but not the same size. Hello? Same shape, not the same size. Look at the portrait they have at the top of page 416. Is that the same picture?
Yeah.
Yes. The one on the bottom is smaller than the one on the top. Now, somebody out there that's really, really insightful, I want you to look at the dimensions of the top picture and the dimensions of the bottom picture. And this one isn't easy to see. Well, I'm going to tell you another big word. You've heard this word before. Proportional. The dimensions of the top picture and the bottom picture are proportional. Does anybody remember what that means? Proportional. Proportion is a fancy way to say two equal
Sides. Parts. Angles.
fractions. Proportional is a fancy way to say that they're equivalent fractions. What do I mean by that? If you look at the top portrait, it's a 30 by 40. The width is 30 and the length is 40. You with me? What's the bottom? 18 by 24. The width is 18. The length is 24. My question, I guess, is that proportional? How could we test and make sure it's proportional? It looks proportional. Is it proportional?
Yes.
How do I find out what this guy is?
You have to go 40 times 18 and divide by 30.
40 times 18, which gives me 720. I got to divide that by 30 and see what I get. What's 720 divided by 30, and guess what it ends up being?
24.
24. This is 24, and now we've proven those two pictures looked the same. They looked similar. Their shape was exactly the same. Their size was different, so they're not congruent, but they're similar, and we just proved it. 40 times 18, how do we find out what's here? Because these two have to be equal. We divide by what's left. 720 divided by 30 is 24, yeah.
Couldn't you do 30 over 40 equals 3?
Either the same thing. Right, 30 over 40, 24 over whatever. Everybody got it? Proportional, fancy way to say equivalent fractions. So we're testing to see if polygons are not congruent, but similar. Look, at home, maybe in one room, you've got a 43-inch television. In another room, you got a 60-inch television. But it's like the same picture. Like maybe your two TVs have the same ratio, length and width. It's just that you go in one room and it's bigger. It's the same picture, but now the length and width have been increased proportionally. Does that make sense? Most standard TVs are 4:3. Have you ever messed around inside your menu of your TV and the settings and all that? 4:3 or 16:9. Those are set ratios that you get your picture on a TV in. So whether your screen is a 32-inch or a 60-inch, it's the same picture, different size. If the settings are the same, because they are going to increase proportionally. Because they're similar, not congruent.
One's HD and the other one's not.
One's what?
One's HD and the other one's 4K.
Talking size. Okay. Look at, let's go to your turn now. We got quadrilateral ABCD and FGHJ. We're telling you, listen, we're telling you that they are similar. First of all, are they congruent?
No.
Are they congruent?
No.
No. Are they similar at first glance? Be honest.
No.
Yeah.
No. Those are not similar at first glance. You look at those two green quadrilaterals in the middle of page 417. When you first look at them, they're not congruent nor similar. But if you look at them a little closer and you reflect them and then make them bigger, now you can see maybe they're similar, right? But listen, if I told you beforehand they're similar, ladies, if I told you beforehand they're similar, you should be able to figure out the length of X. How? Because if they're similar, all dimensions are going to increase or decrease. What's the big P word? Proportionally. All of the lengths will increase or decrease proportionally. So let's look at that quadrilateral. What side is X corresponding to? Using these big words now. What?
16F.
Does everybody see that? Need you to see that X, the side JF, corresponds to AD.
Yeah.
Everybody see it? Okay, now, Elise, walk through this with me. Ready? What does AB correspond to? What is it? No, correspond. We've got two different quadrilaterals. What does AB, are you focused over there, Micah? What does AB correspond to in the other figure? Which side? Go ahead, Elise. Shh. Okay, so AB, what we found out, since we know these are similar figures, Brett, we know that AB is the exact same as FG. Raise your hand if you don't understand that. Okay, so you're either not paying attention, not focused, or you do understand. AB, same as FG. What did they tell us FG was? What did they tell us AB was? How much did FG increase? Times 2. So if Dina accurately said that FJ is the same as AD, what should FJ be?
Oh, well. Wait, no, 8.
8. Because to go from 8 AB down to 4, you had to cut it in half. So you got to cut 16 in half. Because they both have to increase or decrease. What's the big word? Proportionally. All sides have to do that because we already knew going in that they were similar. Does everybody understand?
Yeah.
Yeah.
right. Getting ready for Tuesday's or Thursday's test here on Tuesday. Your homework is page 424 and 425, 1 through 19. Go. Why? Because without the struggle, there is no growth.
I think we should do page by page.
Without the struggle, there is no growth. And we are called to a higher purpose than to sit stagnant and not grow. We, above all people, ladies and gentlemen of Heartland Christian, should be willing and eager to grow more than anyone else. Because we have a higher purpose. What? 1 through 19 today, sir. Not too bad, you're right, because if you look at 1 through 8, you just got to match them, so you only got to write a letter. Your goal is to be done with most of 1 through 19 in the next 12 minutes, so if you have any questions, I can answer them. Big day for some of you. The difference between 2 letter grades, which one's it going to be? Will it be a C, or will it be a D? Will it be an A, or will it be a B? Will it be a C, or will it be a B? Thursday tells the story. Good question.
No, it's saying the grade.
Well, I know.
I'm gonna be bad with tests.
I guess it's because they did the logical A, B, C, D, A, B, C, D order. And then they said, listen, if you don't get one of those, you're a failure, so they used that. I guess.
But why would you choose Z for the very last one?
True. I don't know. Why did Adam call a tiger a tiger? I don't know. Why did he call a horse? Huh? Dominic, you understand it's a similar question? Like what?
I'm saying that there's like a sequence to it. One grade is later than this.
Well, I'm saying my observation is because you failed to do that, less than that.
The thing is, I will be in your class in July 7. I have 87 in your class. I'm going to do
Okay. Did you hear her? She's going to do bad on the test. What?
I already know I'm going to do bad. I do bad on the
It's Tuesday. The test isn't until Thursday.
I know.
So you're already deciding you're not trying.
I'm going to try my hardest.
Wait. When you, listen, you do know that when you say you're going to try your hardest, that there's true hardest, then there's what you convince yourself is your hardest, right?
The thing is, like, I understood at the beginning, like, 100% when we started this chapter 8, and then like the middle, I was like, okay, I swear to get this, and then you end up
If you would start working, maybe we could clear some of it up. Let's go. Whoa! There's far too much noise and disruption for people that, some people are truly concerned about their grade, and you should start feeling that way. And I need to know if there's any problems you're having so I can help you through them. Raise your hand. Micah, when you do that, you start a domino effect of all the desks being out of whack. Would you please move your desk back? She's got cuties, not cooties. Well, if you go behind Casey, between Casey and Jonathan, maybe you could see. Anybody not done with 1 through 8 yet? Basic definitions, okay? Any problems with 1 through 8? Noah? Hold on. Any problems with 1 through 8? Are you stuck on any of those definitions? You are? Go ahead. Okay. Dilation. That's something we didn't really talk about yet, and it won't be on your test. Listen, dilation means you made it larger, like what we just did with similar objects. That picture went from this size to this size, so we made it larger. It's the same exact shape. We just made it larger. Go ahead. Yep. Actually, listen. Actually, dilation is kind of, see if you remember this from 5th grade. Dilation is kind of like acceleration. Usually when people use the word dilation, they make it larger. Usually when people use the word acceleration, they go faster. Acceleration actually means to go faster or slower. And we use the term deceleration to go slower, but technically, scientifically, acceleration means to change your speed. Dilation means to make it bigger or smaller, but usually people use it to make something bigger. And they use the word shrink to make it smaller. Okay, you wanted number 10, Noah?
Yeah.
Okay, Noah, what do you know about the sum? You know what the word sum means?
Yeah.
Adding two things together. What do you know about the sum of angle 1 and angle 50? What do they have to add up to? No. How many?
180.
180. Look, Noah,
Yeah.
help yourself remember that because you know what a 90-degree angle is, right?
Yeah.
So think of your graph, 90 plus another 90. How many degrees in a straight line? 180. So if you know, it's too much chatter. If you know that the total's got to be 180, and they gave you one of the angles as 50, what does the remaining angle have to be? 180 minus 50. You got to find the difference that would make up the 180, 130. Dominic.
I forgot how many sides are in a
Hept. Okay, so you go pentagon. Do you know pentagon? Pent. Pent is 5. So hex, got an X in it, 6. Hept, 7.
Okay.
Okay, and in case you have a hard time with heptagon being 7, just remember hept is kind of like sept. And since September's the 9th, I shouldn't go there. Sorry, I won't go there. 5th graders had their minds blown.
September's the 9th.
Should I go there, Rachel?
No.
He's having trouble with hept being 7. And I said, well, think of hept like sept. Except September's the 9th month. Wait, October's 8 sides, right?
No.
Wait, October's the 10th month.
Oh, my gosh,
You guys remember that in 5th grade when we explained that?
Number 11.
I'm already confused.
How many years in a decade?
10.
What month is December?
October.
12. What's
Hey.
the decade called?
10. DEC is supposed to be 10.
Can you stop confusing
Supposed to
me?
be 10.
You do number 11, guys.
Wait, how do you say 9 in Spanish? Nueve. Wait, November's the 11th month.
You play for number 11.
Oh, it's
All right.
always 2 away.
Yes, there's a reason. David,
Yes.
go ahead.
11.
All right, number 11. What do you know about the angle on the left, the angle in the middle, and the angle on the right? How much do they have to add up to in total?
Oh, I know how to do this.
Listen to me and answer the question. What do they have to add up to?
180.
180 because they make a straight line. So what do you know about the angle on the left? It's 90. It's telling you it's a right angle. What do you know about the angle they already gave you? It's 65.
No, 25.
You got to add 90 plus 65. And what's left?
25.
180 minus 165. Number 11, 180 minus 165. Because you know all three have to add up to 180. Right, Noah? So if you take the 90-degree angle and the 65, you get 155.
You get 155.
I just corrected myself.
Wait, what?
90 and 65,
It's 125. Yeah.
so you end up with 25 degrees.
Yes, that's what I said.
Come on, keep the questions coming. We got 5 minutes.
12.
Okay, so I'm not going to, listen, David, the reason I'm going to someone else right now is because I just did 11, right? And I see you sitting at your desk, no pencil or paper, not even facing your paper. You like to turn so you can see who's behind you, but we need to turn and face our paper. And then I'll answer your question when I know you're focused and try to do it yourself. Brett, number 17. Name the congruent corresponding angles. Okay, they're telling you that number 17, those two pentagons are congruent. First, Brett, you got to focus on those two pentagons and see that they are congruent. Can you see it? The one on the right, Brett, has been rotated just slightly counterclockwise. You see it? Okay, so now, what are the corresponding angles? What angle corresponds to B? No.
Oh.
Brett, I need you to see that the pentagon on the right is look, Brett. Yes, Q.
Q.
B is the same as Q in number 17.
Yeah.
What's the same as A? P. What's the same as C? R. What's the same as E? T. And the same as D? X. You see that now?
No.
They're telling you that the two pentagons in number 17, Micah, are congruent. They already told you that. Knowing that, you need to be able to see, David, that the pentagon on the right, the PQRST, is taking the one on the left, David, and going like this. Look, it's taking the one on the left and going, just tilting a little bit to the left. So the corresponding parts are BQ, AP, CR, ET, DX. Questions? You got like 2 minutes. David. Okay, 12. What do you know about,
I don't know what they're asking.
it says they want you to classify the polygon. So first of all, let's everybody listening? Number 12, in case you did it wrong. Classify means you can classify a triangle according to its sides, according to its angles. So according to its size, what do you call that? I'm sorry, its sides. They told you that two sides are congruent. What's that tell you about that triangle? It's not equilateral. What is it? Isosceles. Any triangle where two sides are the same, Casey, is isosceles. What else do you know about that triangle? First of all, does it have a right angle?
No.
So it's not a right triangle.
It's a left triangle.
Okay? Does it have, are all the angles cubed?
No.
No! Not all the angles are less than 90. So wait, if it doesn't have a right angle, it's not a right triangle. If they're all not less than 90, it's not a cute little triangle. What's that leave? If one of the angles is greater than 90, it's what kind of triangle? Obtuse. So there's two if you don't have two answers, in number 12, you better fix it. It is obtuse, according to its angles, and it's isosceles, according to its sides. Let me say that again. Number 12 has two answers. It's obtuse because there's an angle greater than 90, and it's isosceles because two sides are congruent. Cheers. 15? In a heptagon, whoa! What do you got to remember in all polygons? N minus 2 times 180. That's all you got to remember. Heptagon has 7 sides. What's 7 minus 2? 5. 5 times 180. Boom, done.
900.
Cheers. Tomorrow we'll be able to do just the whole period review because we'll go over 1 through 19. We'll do 20 through 29, and then I'll give you practice questions for Thursday's test. Hint, hint. The things we do tomorrow are going to be like almost identical to the things that are going to be on the test. We're just going to tweak it a little bit. So if you can do the things tomorrow, you should be able to do the things on the test. Even if you can't do them tomorrow and we do them together and then you study, come Thursday, Jordan Wright will be I knew her name was right, but I didn't know it was always right.
Alright, let's